Hi gang, welcome again to Reedy's Geometry, and we're starting chapter 2 today, and we're talking in chapter 2 about logic, and logic really is just an analysis of arguments or of right thinking. And we talked about that a little bit in chapter 1, but what we're going to be doing now is taking statements that really could be anything. They may not even be mathematical statements, and we're going to sort of analyze them in terms of their truth or their falsehood. All right? That's an important thing for everybody to be able to do in decision making or in just analyzing if arguments are correct or not. Straight thinking and correct thinking is something that I hope you strengthen in this course so that you kind of come away with that. We talked about that before. So now we're going to kind of get into the meat of it. And logic has its own, what we call symbology, symbols that we write. What we say is one thing, but when we refer to something on the page and write it, it's something else. In math, there are plenty of examples of that. When we say equals on the page, it's 2 lines, right? That equals on the page is a symbol of the word equals, and it means 2 things are the same. So we're going to talk about some symbology, some symbols that we use in logic. The very first thing we're going to have to talk about is sort of the building block of logic, and that is a statement. What's a statement? Well, a statement is something that you claim, and it has to be considered either true or false. All right? You may not know right off the bat whether it's true or false, but a statement is something that can be considered true or false. All right? You know it has a truth or falsehood. You may not know which one it is, but it's making some truth claim. All right? It's truth or falsehood. Those are the only 2 possibilities that a statement could have. And we call those possibilities, that statement's truth value. A truth value could be true, or a truth value could be false. There's no in between and there's no maybe. All right? And the fundamental thing it boils down to is what we call the law of contradiction. And that is 2 things that are opposite each other cannot both be true at the same time and in the same way. For example, as I look out my window in this building, I see the sun's out, there's not a cloud in the sky. And if someone says to me, it is raining right now where you are, that would be a false statement. That it is raining right now where I am as I shoot this video, and that it is not raining right now where I am as I shoot this video cannot both be true at the same time. If one is true, the other has to be false. And I hope you understand that. Given that, we're going to start talking about statements. And the statement can be, it is raining. The statement can be, x equals 2. The statement can be anything. And in math, when something can be about anything, we use a variable for it. And the variables we use a lot in logic, and you can use others, but we usually use P and Q. All right? Now, we're going to walk through some statements. Now, let me give you some examples that are not statements. Is it raining outside? Okay, would that statement be true or false? Well, you don't know. It is a question. It's not a statement at all. How about this? Wow! Is wow true? Well, you don't know. You can't give it a truth value. You can't consider that truth or falsehood. So just wow alone is not a statement. A statement's got to be something that asserts something to be true or not true. All right, so that's what a statement is. Now let's talk about what we call a conditional statement. So we're going to put 2 things together. It is raining outside. I will take an umbrella. And we use the words if and then to connect them. If it is raining outside, then I take an umbrella. And that kind of a statement is called conditional, because whether or not I take an umbrella is contingent upon or conditional upon whether it's raining outside. So there's an if part of the statement and there's a then part of the statement. All right? the statement can be raining outside, take an umbrella, or it could be anything. So we're going to call the statements P and Q. If P, whatever P happens to be, a statement, then Q, another statement, we say in logic, P implies Q if we mean if P, then Q. All right? So rather than saying if P, then Q, we just say P implies Q, and it means the same thing. And the symbology, what we write on the page, is P and then a little arrow and then Q. That means if P, then Q. If some statement P, then some statement Q. All right. Now, if a statement P has some truth value, then the opposite of its truth value is called a negation. Negation comes from the word negative. And the symbol we use in logic is a little squiggly. So squiggly P is the opposite truth value of P. All right, so if I say, it is raining outside where I am right now, then not P would be, it is not raining outside where I am right now. It's just the opposite truth value. Right now, Q implies P is called the converse of P implies Q. What you did was take the if and the then and interchange them. If my original statement was, if it's raining outside where I am right now, I will take an umbrella. Then if I said, if I take an umbrella, then it's raining outside, that statement would be the converse of my first statement. All right, so that's converse, taking the if and the then and flipping them around. Now look at this one. Not P implies not Q. That took my original P implies Q. It didn't flip around the if and the then. It just changed the truth value of each one to their negation. So if my original P implies Q is, if it is raining outside where I am right now, then I will take an umbrella. The inverse of that would be, if it is not raining outside, then I will not take an umbrella. All right? We've not established any truth values yet. We're just talking about what a statement is, what a conditional statement is, what negation is, and we've talked about converse and inverse. So let's talk about contrapositive. Converse is take the if and the then and switch them around. Inverse is leave the if and the then but negate them to their opposites. A contrapositive does both at the same time. So you start with an original P implies Q, and you flip it around to Q implies P, and then you make them both their negation. Not Q implies not P. So not Q implies not P is the contrapositive of P implies Q. All right. Now, if then is not the only way to put two statements together. You can put them together with what we call conjunctions, and we have that in English, in grammar. All right? This statement and that statement. P and Q. And we denote that, our notation or our symbology in logic is this like upside down V. So that's P and Q. That's how you write it on the paper. And what it's called a conjunction, and it just means P and Q. That's what you would say. This is P or Q. That's a right side up V. P or Q. That's what you'd write on paper. That's the symbol. It's called a disjunction. And you would just say it as P or Q. All right. That's sort of an explanation of some of the things on your note card. Now, over the next couple of sections, we're going to be using this symbology and analyzing arguments a little bit. So let's get to some examples from 2-1.